Alright, so I'm going to follow the procedure on your ellipse lab. Number 1 says cut a piece of string approximately 22 centimeters in length and tie the ends together. Having done this before, if I went 22 centimeters in length, the string would be a little too short, so I actually cut it to 25 centimeters centimeters. On a plain white piece of paper, draw a straight line across down the middle of the paper. Now, it's important that you realize first thing you need to do is find the dead center of it. I did this by folding it lengthwise and then widthwise so I could get the center. You're going to want to have it long ways on the side. So the center is going to be where both of them intersect. I'm going to do that first. Put my little hole there for my thumbtack. Then I'm not going to worry about drawing that straight line lengthwise down that because I already have it on the fold. So it says near the center of this line, draw 2 dots 3 centimeters apart. So I need to have them 3 centimeters apart. So I'm going to start in the center. I'm going to go 1.5 centimeters to the left, 1.5 centimeters to the right, and that's going to give me 3 centimeters. So putting this, setting this up right in the center as 1.5. Come over here to the 0. Come over here to the 3 centimeters. So my thumbtacks are now 3 centimeters away from each other. Placing the paper on cardboard, I got the thumbtacks in. My thumbtacks are at my focus. Loop the string around and draw my ellipse. This is going to be ellipse 1. Alright, measure the distance between the thumbtacks. So if I did a good job, it should be about 3 centimeters, yes? Alright, so if I look at it, my distance is 3 centimeters between my foci. Next, it says to measure the distance, to record this on the, measure the length of the major axis. The major axis is this diameter that goes through the 2 foci. So like for us, it'd be like the equator idea. So if I'm going to measure that, it's the nearest 10th, 17.2 centimeters. I'm going to do all the measurements and then I'll come back and do the calculations for the eccentricities. Next, it says move each tack out 1 centimeter and draw the next ellipse. Alright, so I'm going back to where my hole was for my thumbtacks, moving each one out 1 centimeter. I'm going to repeat. Now, I need you thinking from the notes. Should it get more circular because the foci points are further away, or should it become more elliptical? Okay, I'm going to label that one ellipse 2. Same thing, I go back and measure between the 2 foci point. And I did a bad job on this one. 5.2. 5.2 centimeters is my distance between my foci. My major axis, I'm looking at 15.1 centimeters. I'll put the data up for you in a little while. Okay, we're gonna do the same thing again. Move it out and see if I can do a better job on this one. Move it out 1 centimeter out. One centimeter out. All right, gonna do ellipse 3. Ellipse 3, here we go. Put in too high on the pencil point. That's my problem. Here's ellipse 3. Gotta measure my distance between my foci. Okay, 7.2. So I still got my issue from before. 7.2 centimeters. My major axis, 13.2. If you keep reading, I do it one more time. So add another centimeter. On each side. 1 centimeter there, 1 centimeter here. Okay, notice what's happening. It's getting more elliptical, it's getting less circular. Ooh, gonna be tight. This is why I did 25 centimeters and not 22, as it says in the direction. It's ellipse 4. Distance between foci. A little error on that one. 9.4 centimeters. Major axis. 10.9 centimeters. Then I got to flip over to procedure 12. It says place a dot in the exact middle of the first 2 foci, which is the dead center, which I did earlier. Using a drawing compass with a red pencil, construct a circle. Place the point of the compass in the center of the dot. Extend the compass along the major axis so the pencil touches ellipse number 1 on the major axis. This has to be. This will be the radius of the circle you are to draw. Okay, so putting my compass in dead center, I'm going to extend it out to ellipse number 1. And I am going to construct my circle. Yeah. Okay, that is going to be my ellipse 5. Now remember, a circle is an ellipse. Its foci are just in the same exact location. So going back to my data, since I didn't have 2 different foci, my distance is 0 centimeters. My major axis when I go to measure is 17.5 centimeters. All right, so get that data down. I gotta go get a calculator for calculations. All right, so eccentricity, you're going to calculate it to the nearest thousandths place, so that's 3 place values out. Eccentricity also has no units, because when you remember, whatever you do to the numbers, you do to the units. So centimeters divided by centimeters cancels out. So if I have 3 divided by 17.2 equals 0.174. Ellipse 2, 5.2 divided by 15.1, 0.344, 0.344. Ellipse 3, 7.2 centimeters divided by 13.2 centimeters, 0.545. Ellipse 4, 9.4 divided by 10.9, 0.862. Ellipse 5, 0 divided by 17.5, 0. All right, so get your values in. If I look at your values, remember, the larger the eccentricity, the more elliptical the object is. So if I look at it, it makes sense because ellipse 4, by the shape, is the most elliptical. Obviously, since I use the compass, ellipse 5 should be a circle. So its eccentricity is 0. The highest you can go is 1. That means your foci and your major axis are the same. That's a straight line. The lowest you can go is 0, which is a circle because you don't have 2 foci, they're in the same location. All right, let's just look at the question and see if there's any issues. What changes takes place in the eccentricity of the ellipse when you increase the distance between the foci? So as I went from, this is going 1 through 4. Do not include ellipse 5 in this question. So look at your data. As I move the thumbtacks out, what happened to my eccentricity? Which of the 4 ellipses you drew? So it says not counting the circle, so that's number 5, was the most eccentric. So it's got the highest eccentricity. Number 3, which of the 4 ellipses you drew, not counting ellipse 5, was the least eccentric? So the one closest to a circle, or that had the lowest eccentricity. What is the minimum eccentricity an ellipse can have? I literally just mentioned that. What is the name of that geometric shape, figure which has minimum eccentricity? I ironically just mentioned that to you too. How does the numerical value of E change as the shape of the ellipse approaches a straight line? So does the eccentricity increase, decrease, or remain the same is what you're looking at. Straight line would be, it's 1, right? We just talked about that. Where is the sun located on the diagram in the Earth's orbit? This is out of your notes. All right, you should see the sun is located at one of the foci. So one of those locations where I put the thumbtack. What was the eccentricity you calculated for number 1, which is rounder or less eccentric, the orbit of the Earth, or ellipse 1? So you got to go to your reference table, find out what the eccentricity of Earth is compared to what we had for ellipse 1. In the table, eccentricity of planets, the planets are listed in order by their distances from the sun. Is there a direct relationship between the eccentricity of the orbit and the distance of the planet from the sun? So you're going to compare as they are, distance from the sun. Is there any relationship to the eccentricity? As they get further from the sun, are they more elliptical? Are they less elliptical? Or are they always eccentricity all the same? Or is it random? It's going to be one of those. List the planets in order from increasing eccentricity. So find the planet with the smallest eccentricity and list up to the planets with the largest eccentricity. Conclusion. Describe the true shape of the Earth's orbit. Look at the eccentricity of the Earth. Is it a perfect circle? Is it extremely elliptical? Or is it slightly elliptical? All right, good luck on Lab 26.